Okay, last problem today for altitudes. Problem 7.25. The altitudes of triangle ABC meet at point H. At what point do the altitudes of triangle ABH meet? How about triangle ACH or BCH? Alright, well, let's draw our triangle. I'll relabel them in a minute, but we have our triangle here with points A and B and C. Okay, now let's draw the altitudes. So we got perpendicular line from A to BC. And actually, let me make this a acute triangle to make the work a little easier. Perpendicular line from C to AB and from B to AC. And they're all meeting at that point right there, the orthocenter, which I will call H. So, it wants us to figure out if the altitudes are meeting at point H, how about triangle ABH? ABH. Where would those altitudes meet at? Well, let's construct them. So, what I am going to do is we're going to draw the segments of the altitudes and get rid of all the extra lines in the problem that we don't really need to look at. So let's see. Hopefully this works fine. Nope, it doesn't. Of course not. Alright, so there we go. Let's hide all the lines going all crazy everywhere. And let's see. So I want to find out where the orthocenter of ABH is. ABH. So I'll even make it a different color. A to B to H. And we'll make that a nice red. Where are the orthocenters they are going to meet? Well, I see that the altitude from H is already drawn because the altitude is HL. How do I know that? Because I know HL is 90 degrees with the base because it's a part of the altitude CL. So we already have that altitude drawn. Well, how about the one from A to JB? Alright, is it not gonna... Alright. And then we have to make another segment like this. And then that means I'm gonna have to make one like this too. Okay. And... Alright, so... Draw the perpendicular line from A. Now the base would be at BH. So right here. It's making a 90-degree angle with, but it's going through C. That's funny. I mean, that makes sense because if we extend the base BH, that would be the line BK. And since the altitude can hit the extension of that line, then AKB is making that 90-degree angle. Okay, it's a little weird, but sure. Now we have to draw the altitude from B to AL, or AH, sorry. So, what we have just noticed is that all of the altitudes of ABH are meeting at the third vertice of our triangle C. So, we know that ABH has orthocenter at C. Alright, that's a little weird, but whatever. Let's try the other two triangles we need to work with. So, next triangle I'm going to work with is ACH. ACH. And I'll make that triangle purple. Okay. Why did it do that? Whatever. There we go. Alright, so let's draw the altitudes of AHC or ACH. Well, the same logic, I know that HK has to be the altitude from H because it's making that 90-degree angle and it's a part of the altitude BK. So now I just have to find the altitudes for the other sides or the other vertices. So if I draw the altitude from A, it has to hit the base HC or be 90 degrees from it. Whoa, well that's meeting at this way. I mean, it makes sense. CL is an extension of CH, the base, and A is making a 90-degree angle at CL. Therefore, 90 degrees with the base. Okay. Well, how about C? If I draw the altitude from C, it has to hit AH, or the extension. And, well, what do you know? It's actually hitting at the location B. So the orthocenter is at B. Now I can probably make a nice prediction about where the last one's going to be, BCH. If ACH has orthocenter at B and ABH has orthocenter at C, I can probably conclude the last triangle is going to have an orthocenter at A. But let's just make sure. So I'll highlight the triangle we're working with, BCH, and we'll make that a nice blue. Green. Yeah, that looks fine. So again, what just happened? Whatever. Alright, we know what triangle it is. So we know that HJ is the altitude from H. Let's draw the other two. So the altitude at B would have to go through the base HC at a 90-degree angle. And of course, C has to go through BH. And they intersect at A. So, just like we predicted, the orthocenter of BCH is at point A. Well, that's an interesting property. So, when we make the original orthocenter, that point H from triangle ABC, and we break down the triangles into three triangles from the orthocenter, we end up finding that if we make triangles out of the orthocenter of those triangles is the third vertice of the original triangle. So, interesting property, but fairly easy to prove.